Hello from Amrock Fab Lab and our second Roboticon Live event. Tonight we're looking at Infinite Recharge at Home, and we're going to be discussing some of the different challenges that are related to the Robot Skills Challenge. We've got with us Edgar Allan Ohms team and Royal Robotics, both here in Tampa Bay. And I'm going to pop them up here on the screen and so they can introduce themselves, and we'll get a conversation going here. And you can learn a little bit about their approach to things. If you've got questions about the challenges and some of the different solutions to it, you want to pop them up on the chat. We'll be happy to answer what we can and find answers if we don't have them. So without further ado, I'm going to bring up Nathan and Chase from the Edgar Allan Ohms and Teddy from Royal Robotics and let them introduce themselves. You want to tell us a little bit about yourself and what you do on the team, Teddy?
Sure. I'm Teddy Singoris, as she said, and I'm from Royal Robotics, and I'm the build lead and a team leader on the team.
Cool. And you guys want to introduce yourselves?
Yeah, I'm Chase McNell. I'm Nathan Kutan. We're the programmers on Edgar Allan Ohms.
All right, and I think you guys have you chatted a little bit before we came on, and I think you've got some slightly different approaches to the challenges this year, and it's a totally new experience. So I'm going to let Teddy go first as our guest, and maybe you can tell us a little bit about what you're doing, and then we'll hear from Edgar Allan Ohms and get an idea of what you're all planning to do.
Sure. So this year, well, every year when there's a normal season, we build a new robot. So this year we decided to do the same exact thing. So this year we handed our 2020 robot off to programmers and let them try to figure out path generation and following a path, while we're completely redesigning a robot as we planned to do it as if it was an actual competition. But as most may know, they've said that we cannot until at least June. So that we're still hopeful, so we're building a brand new robot that will be a competition robot to do everything, hopefully. That's pretty much.
And why don't you guys tell us what you're working on?
I mean, our plan is actually pretty similar. We're building a completely from scratch robot this year, trying to make a swerve drive out of it. But we're probably not going to end up doing all of the robot skills. Well, we're going to try. We're going to try to, but we're probably not going to end up doing all of them just because of the fact that we're like not that experienced in shooting balls and all that stuff. But yeah, pretty much we're just building from scratch, making a swerve drive, and just trying our best to make it as good as possible at doing the Robot Skills Challenge specifically. And future years can add on to it.
Yeah, and I mean, something I want to say was we were in a similar boat to what you said, that we were originally going to try and make a robot for competition, and then first said, psych, we're not doing them at all. So we scrapped that idea. But what was interesting was we already wanted to do a swerve drive, probably even before COVID. It was like we wanted to do a swerve drive. That's something we always wanted to do. And then they released these auto nav challenges and stuff that lend itself perfectly to swerve drive. So that was great for us. We were like, yes, swerve drive time right now. Let's go. Yeah. So that's one of the main things on our robot is going to be learning about swerve drive and building that up.
So one of the things Edgar Allan Ohms was telling me was that you guys sort of went above and beyond what you think most teams might want to approach in terms of the complexity of some of your solutions. And maybe we ought to go first a little bit. And Sam's here too. I'm actually going to pop Sam up here. He's all settled in there. We got Sam McAmis with us. He's the coach of the Royal Robotics team. So we just started talking a little bit, Sam, about the challenges this year and the approaches that the teams are taking to it. And before we get into, we were starting to talk about the Ohms taking a rather complex approach to the problem, because that's who they are and what they do, for better or worse. Did as a coach, what did you think of the challenge this year and especially the robot portion of it? Because I know you're fresh from BattleBots. There's a lot of drive challenges related to this game, and how do you make it interesting? How do you make it challenging? How do you make it educational for the students? So if you want to weigh in a little bit on that, what your thoughts were on it.
One of the things I think is so interesting is just like how open-ended it can be. Because like typically like the rules are very specific about like what you can do, and now it basically like trying to make it as open to everyone as possible. Like they've kind of made the rules like, you know, do your, you know, best, you can play on any field. And one of my immediate first thoughts was like when they didn't specify the the field like carpet or anything, was it meant that like there's nothing like in the original rules like stopping you from laying down a bunch of, you know, steel plates like a battle box floor, and, you know, running with, you know, a couple 100 pounds of downforce of magnets on the robot, so that you can basically, instead of having, you know, instead of being traction limited by wheels on carpet, you could have, you know, pretty much you could accelerate, you know, as quickly as you want with if you have magnets. But one of the interesting things was I saw 1678, the citrus circuits. They thought of the same thing, and they asked the Q&A. Basically, they said, you know, right now, like you can put some neodymium magnets on a robot, and this is a safety hazard. Can you please clarify, like via blue box or something, that this is not a safe way to the robot would not be safe to play the game. And so they were like the next rules update came out, and it was like the flooring design is not an aspect of the game challenge. It is just to, you know, make it as available to everyone as possible.
Yeah, cool. I hadn't even thought about that with not having the carpet or flooring designation or identification on there. That's a good point, and really does open things up in a new way.
But yeah, and also like we had to think about, you can basically, one of the first decisions that we made as a team was whether or not we wanted to pursue this as like a skills, like pursue the skills challenge directly, or kind of design for the original Infinite Recharge in the hopes that we'd get a chance to, you know, play in person and design a robot for that, and then do the skills challenges with it. And the students decided that they want to go. They basically decided they want to design a robot for Infinite Recharge, and then basically just play the skills challenges with that, because there's a lot of things that if you're not designing a robot for actual FRC gameplay, it does open up like a lot of, you know, new ideas, well, not necessarily new ideas, but ideas that don't play as well on the FRC field, because like, you know, all Omni robots that can easily, you know, change direction is probably more optimized for, you know, these challenges. And if you don't have to worry about defense, like that might be, you know, a way to go.
Good. Yeah, definitely a good point there. I'm going to add Teddy back in there, and maybe, you know, you can all tell us a little bit about, you know, he's starting to talk a little bit about it. You know, if you want to tell us a little bit about how you're approaching it as a team. I mean, are you meeting in person to do these right now, or no?
Yeah, we're meeting in person 6 days a week, of course, with masks and safety protocols. But we're trying to treat it as much as a regular season as possible, basically so that when seniors leave, there's a peaceful transition to each year, and that they know what to do, and they basically so that the future of the program keeps going forward.
Yeah, that's super important right now is you know, with teams, because you hope that after all this, everything will be able to come back strong. And if you want to make sure that your other team members are ready to roll on that. So very good. I'll pull the Ohms back in here. You want to tell us a little bit about what you guys are doing? I mean, so you talked about it a little bit. And I don't think Sam's heard it. So he's your he's your presenter here. So you're going to tell him what your approach is to the challenges. And you also have, I think, some programming or something you were going to show as well.
Yeah, I mean, our approach to the challenges is pretty similar to yours, in which it is that we're going to be building an entire new robot from scratch. We're going to be aiming actually to go for a swerve where we try. Last year, we decided on doing 2 regular front wheels, and then the back were 2 omnis, and it ended up being that it would swing around and hit its back into towards every time you turned, and just random things. So this year, we're just going to go full-on swerve drive, and we're going to try and go for all challenges, though, I mean, we're not that good at shooting balls or anything like that. We're not a hugely experienced team. So we're kind of just going to cut our losses and see how much we can get done.
But we are definitely the autonomous challenges, I think, is where we're most excited. Specifically, we're both programmers.
Yeah.
And if you know anything about Edgar Allan Ohms and programming, we are mildly insane with what we do. If anyone's not familiar with the auto nav challenge this year, it's pretty much there are 3 different paths, and the robot has to traverse those, I believe, as fast as possible. And so for our approach, we pretty much wrote a system that just takes in the points and goals and that sort of thing, and automatically produces a path to do it. So it's any arbitrary set of points that could produce, and it produces a path that the robot's going to take, which I want to emphasize for everyone watching is not necessarily the best way to approach this challenge.
Yeah.
We just wanted to.
It's different.
Because you could hard code the paths, right? Which is probably one of the more efficient
It
ways
probably
to
will
do
be
it.
better way than ours.
But
realistically.
we like the challenge of those sorts of things, and so our system, which I will screen share in a second, we wanted to make it so that it works for any paths of any kind, and all it needs is just the points, and it produces it.
Yeah.
So, Mr. Do you want me to screen share that
One
now?
demo? Sure. Is it started?
No, hang on.
Might need a.
Open system preferences.
All right, sorry, we
Hang
gotta
on.
get permissions first. You have to. We don't have it open yet.
Yes, it is.
Oh, it is open.
Would you have any thoughts on what they were saying there, Sam?
I think like this is an excellent year to start a swerve drive because you've got like plenty of time to work it out because you've got basically through I guess the end of March, right? To
I mean, we can try it.
It's do entire screen.
kind of refine your program. So like you have like it is a good year I think to like work on swerve drive. And programming isn't really my specialty. So that sounds cool though. I don't have much input on that side of things. Teddy might. He's working on some programming this year.
I honestly think it's really cool. Can't wait to see how it. I think you guys are doing a demonstration, so I think that'll be really cool to see. We're hard coding ours with paths and hopefully, but we'll see how it pans out.
So they just kind of threw themselves out of the live stream. They'll be back briefly. And I'm sitting here playing around with these things as well. So obviously there are challenges to doing these things. There's challenges to doing them online. And, you can see what happens when these things are going on. And these are the things we have to deal with, right? So when you're trying to do stuff remotely and trying to get them to work, things don't always go right. I think they're back with us. And I think you're still trying to get wait, they've almost got it. Teddy out there. So, as far as do you have all of your students this year you have new students on your team this year, Sam?
Yeah, we have a ton of new students.
All new or a lot?
So I'd probably about a third of the team is new.
What a year to start.
Yeah, and then probably close to a third of the team is seniors too. So like this is definitely like a transition year for us.
Right. Yeah. You guys ready to go? Do you think you got it? All right. I don't see your screen though. I see you guys. I don't. All right. I see it. All right. I'm gonna hop out here and pull their screen up.
Okay. I can't hear anything.
Oh, we're muted.
You might have us muted.
That's a pretty cool effect there.
It's the stream key.
No, it's not on there.
It's on the URL.
It's say stuff like people.
Yeah, I can hear him now. I hear you
Okay.
guys.
So, so for anyone who's not familiar with the way that any of the at-home challenges are laid out for the skills, there is this sort of grid on the ground, and it's similar to what I have up on the screen here. And the different challenges use the different points in different ways. So specifically for AutoNav, there are different paths that are defined by different points. So we have preloaded the paths, for example, here. So this is the barrel path. And so essentially what this program is, it's sort of two parts. There's an engine in the background that we wrote that essentially takes the list of points on the grid that we need to go to and a list of points that we can't touch, and then it computes the path. And then we just have this demo visualizer essentially that just has this dot moving around with the path. Obviously in the final version, we're gonna take that essentially engine code and write it to have the robot move in this path.
Yeah.
But the cool thing about this is that the path itself is not hard-coded. It's only the program only gets the list of points in the grid layout, and it's computing the path by itself.
Yeah, the path is literally just a spline that's computed, or Bezier spline.
That's really cool.
And so these are the three paths that first is provided. And just for fun, we have custom path designer. So we can, for example, add different goal path. Let's say we want it to do something like this. And then let's say we say it can't go along these three dots there. It can go ahead and save that, and it will compute a path that
can go between diagonals.
Yeah, it can go between the diagonal ones, which is allowed in the first menu.
Yeah.
But it will go to the points that it needs to, and it will avoid touching the ones that we said it can't. Actually, just to make that a little more difficult, I'm gonna block that one and that one.
And yeah, now move around all those obstacles.
That's really impressive.
I don't know if we want to talk about like the technical aspects of it.
You can.
All right, so pretty much all it is it's two different parts. The first part is the A-star pathfinding. That's a pathfinding algorithm that's based on cost. So it's a cost for you to move to that next square when compared to how far you are from the start and from the end points. So using that, you can compute what's the literal best method for you to get between two locations. Now, it's not the fastest version of this, and we may actually have to rethink it if we want to write like a real-time one where we just click on a screen and our robot goes somewhere else. But for right now, it works fine. And I mean, it seems to be pretty dang accurate. And then once we have that path, out of it, we get a list of points. So we pretty much get the points for every single one of these squares that are in green. So all we know is the coordinates of every single one of those squares. So from there, we need to draw a path that the robot can follow, right? We can't just have a list of points because then what's the robot going to do? Just move towards the point? It's going to be very janky. It's just going to move around. So what we do is we draw a Bezier spline. So that's pretty much just a piecewise function. We're containing a bunch of Bezier curves, and it draws it between every single one of those green points. So pretty much what it is it's a Bezier between this first one to this one, another Bezier between there and there, another Bezier between there and there, and that's how we draw the path. And from there, you get a full function out. Using the function, we can input it into, well, we haven't done this yet, but this is what we would do. We would input it into PID, just a PID control loop, and then we can try our best to stay on that path as we move around using just the accelerometer and probably some estimation using LiDAR. Or an IMU in total, because we got to worry about drift. And that's pretty much it right now.
Cool.
Yeah. Oh, want me to stop sharing here? Cause I can't really switch screens without showing.
And so, yeah, obviously that's a lot of theoretical stuff going on there, right?
Mhm.
And putting it to work on the field is going to be something different.
Oh, yeah.
And that's one of the really cool things about this season is you can't experiment with this stuff. And try these different things, and why not, right? This is a great opportunity to do that. And I don't know, we're also doing some of the, are you guys doing the driver skill challenges too? would you
Yeah, I
decide?
think we are, but we don't really know about that.
Yeah.
Are you guys doing that at Royal Robotics? You doing some of the driver skill stuff?
I think our goal is to try to do every single challenge and
Okay.
hopefully do well on.
Yeah, I'm pretty sure we are going to at least do it.
We're gonna try every single
Yeah.
one. I think the ones that are least likely for us is anything with ball shooting.
Yeah.
Just because we've never made a ball shooter ever.
And we haven't even started designing one. So
But definitely all the autonomous ones, assuming we have the mechanisms on the robot, like we're definitely going for it. That us, and there's another third programmer who's not with us today, but we're all super excited about the autonomous in this. It's probably the most autonomous we've had in the first game. Most autonomous in first games is pretty much just
move
go
forward.
off the line. Occasionally you have shoot a ball, but like for infinite recharge, for example, our robot could lift and it could spin the wheel, which were good for the game, but all we could do during autonomous was move forward. It was super boring. So this year, the fact that we have all this autonomous stuff to play with and that's really interesting to us is really cool. That's what we're excited about.
Yeah, I think that's a good point because I've talked to a lot of students before who really wanted more autonomous in FRC, right? It's such a big field. You want to be able to do something with it. Now you've got pretty much a quarter of a field to sort of play around on. I'm curious as to would you like to see as we move back into full games more autonomous programming in FRC games? I think that'd be really cool. It'd be neat if to set some sort of precedence for that. Yeah. But how do you guys feel about that at Royal Robotics?
I'll let you go first, Mr. Ricky.
I think it would be cool. I wouldn't. It might be cool to extend it autonomous to like 20 or 25 seconds. Give teams a little bit more time to do stuff, so you're not like quite so rushed. Or if you want to rush and do even more, it'd be cool. But I think a lot of teams even struggle just to move off the line sometimes, and there's definitely I think there's even more disparity in first when it comes to like programming than there because like you can there's quite a few like off the shelf things you can do as far as like versus like now like planetary gearboxes and wheels and even like full mechanisms now that you can build. And I guess programming there's now like you've got more like you've got Pathweaver and stuff to do that, but it is kind of I think that would be my only concern about like making like giving more autonomous more time to autonomous would be the teams that like can only move and can't really do anything for the rest of the the time that you would have. I think that there's I guess that's really all I had to say on that.
So I really agree with Mr. McCamus. I think at least with our team, we don't get our robot done quick enough so that programming can have the time it needs, especially not counting this year where you really don't have anything from a prior year to go off of that you can just hand off to them. And at least with us, yes, we had a fairly good and okay autonomous last year, and we do okay at autonomous, but I can tell you it's really not our strong suit, at least with us. So it's kind of I would honestly be afraid if they did more autonomous. I'd like 10 seconds is fine, but like more challenges, I think it just, at least not every team I don't think would benefit. I don't know if that's the right word, but.
And to add on to that, I think the other thing I think is maybe I wonder if there would be a way to incorporate more like autonomous challenges that are easy to do mechanically, but difficult to do like programming wise. Something like the Ohms are talking about doing with the autonomous challenges, where it really would benefit the teams, like something that's because a lot of like the advanced autonomouses now rely on an advanced robot. So like there's really complex autonomous that you can do in the recent first games. Like if you look at like 254 is like 4 cubes, got like 4 cubes on the scale in 2018 in autonomous. But you have to have like a complex mechanical robot to do that. I think if there were more challenges that were mechanically easy to do, but software-wise difficult, I think that would be pretty neat.
Yeah, I think that's a really good point. Right now we have a weird amount of time with a robot that we didn't have to build, right? We've been using the same robot pretty much from last season. And that sort of changes the dynamic. If it was a regular season where you had to build from scratch for a brand new game, that would definitely change things up. Put it back. So I think this has given us a good opportunity to look at some new things, and I'm really curious to see how things change up over the next couple seasons with some of these opportunities. Some of these are opportunities, some of them are challenges. So going back to some of the approach for these skills challenges, there are some other components to it, and I don't know how much you've all discussed in your teams, Sam and Teddy, in terms of the presentation and how you're going to do all these things and for the challenges and these. So have you all looked at any of that? And do you have a game plan for March and April for this portion?
Honestly, on my side, I don't think we have much of a game plan. Our goal right now is trying to get the robot ready and start working on those reports that you have to submit on March 4th, probably the week before or a week and a half before. Once the robot's starting getting built, take the people that are on CAD and marketing, put them together to get the submitted work. So we honestly, I don't think yet have really, at least that's my view.
Just like the regular build season, right? Just
Very much.
That's funny. Whoops, I've lost him. I'm keeping my volume down so I can't always catch everything. Did you guys want to address any of the what your next steps are from what you've got now?
I mean, our next steps are mostly going to be seeing what we can get done in this time period. Like, we're really what we're saying here is that we want to build a swerve drive. We want to build like something to shoot balls and all that stuff. But reality is, we are still on a time crunch. All of us still have school at this point, and we're gonna end up having to just try our best in doing this. I mean, programming is good because with programming, we can do it from home. We can just this entire program, well, most of the program was written from home. Part of it was written while we had a meeting, and it's something you can't really do on mechanical side. So we kind of just have to see how it goes. And I do agree, like, there is a difference between like what you can do mechanically and programmatically, especially with what most teams can do. Most teams are a lot more limited in terms of their mechanical capabilities, while they could do a lot more programming, though of course they need the skills to be able to do that programming. Personally, I would argue programming might even be harder and take longer to learn than even learning how to build mechanical stuff, but it's kind of just a different mindset. It's like comparing apples and oranges.
And I think another thing, and I think a lot of teams experience this, is that the programming is often limited by the engineering because, I mean, especially with our team is notorious for this, they get the robot like maybe a couple days before like competition, and then we get to use it. That's obviously something we're trying to avoid this year because the programming is so complicated from our perspective. We're like, please give it to us more in advance. But I mean, Infinite Recharge, we were like, yeah, they'll give the robot to us like, a week or two in advance. It was like 2 days. We finished like the alignment code literally day of.
We finished the alignment code 1 minute before it got loaded onto the truck. So it was like really close.
But yeah, I mean, the thing is like programming, you can only do so much programming without the engineering being done, right?
Yeah.
Like, as an example here, we can talk about this engine, write this engine all day that does these spline curves and pathfinding and all that, but it's not bracket, can't just slap that onto a robot and call it a day. There's a whole lot of other parts that this needs to be translated into robot. How does it move? How does it stay on the path? That sort of thing. That we really need the robot for. And if you were to introduce, we're talking about more autonomous stuff. it's sort of limiting because of the fact that you need the engineering to be done.
Yeah, what we have here is pretty much like 2% of the entire problem. We have a ton more to do after this, especially translating the theoretical world of a Euclidean space into our real world. So
That's pretty good. We do have a question. I popped it up there a little bit earlier. Sorry about that, but there's your question. And
So
you want to take that, Teddy?
sure.
Or
So
Sam?
to answer that, oh, can you hear me?
Yeah.
Okay. So we are sticking with a 6-wheel tank drivetrain mainly because it's what we know what works, and since programming is not really our biggest strong suit, it's easier for us, especially with the reference code available for like following a path and stuff. It's easier to do a tank drive type system with not going something complex like Swerved, which I think Edgar Allan Ohms is doing this year, as they said earlier.
yeah.
Yeah. And maybe people didn't catch that earlier. I don't know if you got a chance to show Sam the stuff you were working on with the Swerve drive. You guys got that component.
Oh, yeah.
We have this, which is
One
one of the
modules.
serve drive modules here. So if anyone doesn't know what serve drive is, it's essentially like 4 caster wheels, essentially, where there's a wheel that moves, and then it also rotates like this. And all 4 wheels on the robot can do that, so you can essentially move in any direction at any time. It's very similar to Mecanum. However, the advantage of Sword Drive over Mecanum is with Mecanum, you're very susceptible to being pushed around by other robots. There's a lot less friction with you on the surface, whereas with Sword Drive, you can add measures to prevent things like that. And also you can generally move faster with Sword Drive. But fundamentally, they serve the same purpose. They allow you to move the robot in pretty much any direction.
You guys hadn't done a Swerve drive before, right? This is the first time. So what did you think of, you ordered, this was the, and it's just the Andy Mart Swerve drive. What did you think of putting it together and the experience of doing that portion?
It was a process.
Half parts didn't end up fitting together, and we had
No,
to put
well,
in the freezer.
they did. So like the thing is, with especially robotics kits, right? The manual makes it look easy, and then you actually start putting it together, and it's not easy. And specifically, a lot of these parts are very tight, where they didn't really want to go in, as the instructions just said, put it in. And it didn't work that way. So, like Chase said, we had to put some stuff in the freezer,
And we
and
spent like an hour banging it with a hammer until it went in.
yeah.
So
I think the testament to, I think the trend with our team, I think with everything, and it's true with this too, is that like I would say approximately 50% of all of these we finished all 4 of them. 50% of them took around 7/8 of the meeting, and then the last 50% was done in like 20 minutes.
Yeah.
That tends to be how our team operates. But once we figure out the problems and how to solve them, such as putting things in freezers, we end up running through it and getting it
What
done.
do you think of the freezer and hammer approach, Sam?
It's about when you gotta get things to fit. We tried torch too.
oh,
I mean, if it works, it works, right?
Sometimes they're very expensive. So that's the other thing we need to consider when we're doing these things too, at the cost of these things, right? They're not cheap. So
yeah. Can you afford like one of these?
Maybe
So,
the oven. But the part you gotta get bigger in the oven, man. Maybe not a torch.
I don't know. We don't have an oven here though. But do we? I wouldn't be surprised if there's an oven somewhere in here.
there may be. So is there, are there other considerations that I'm asking, Sam, this one here, are there other considerations that you think with respect to the new season challenges for students with the robotic skills components that maybe we didn't touch on here yet, that are worth bringing in for students or exploring that maybe they wouldn't ordinarily have an opportunity to explore?
I just come back to like the way the challenges here. It says that you have to have like a competition legal robot, but there's a number of like game rules that aren't the robot rules that basically don't don't apply, because basically it says that your robot has to like pass inspection, but it doesn't, like, it can do things that would normally be illegal because they're game rules, not robot rules. At least that's my interpretation of the way it's written. So like, they did clarify that magnets aren't legal, but there's, I believe, you can use like a vacuum system to hold the robot to the ground, because you're not normally allowed to use that because it would pull up the carpet and damage the carpet, and so it's a field damaging rule that it's not allowed. But the rules don't tell you that you're not allowed to damage your own field. So in going by that, I think vacuum systems should be legal this year.
For the record, they're not allowed to damage the field at Amrock.
So for the record, like, I don't think that we're pursuing that. But it's interesting because there's a lot of things that like you think normally like, oh, you can't do that because it's against, the rules, but they made sure that certain like game rules were called out, like the starting configuration and forget what other ones were, but there's certain ones that they don't want to make you to make a robot that does something too crazy, but there's a lot of like game specific rules that aren't a part of the skills challenges. And so that was just another example.
How did you all mark? Are you using a carpet or are you using a solid floor for yours? I mean, for Royal Robotics.
Right now we're just using the asphalt out back. We have basically a parking lot just outside the room, and that's what we're using now. I could see us like getting a carpet and doing it later, like in March when it comes to like doing the actual runs. But for now, like that's good enough for what we're doing.
Yeah, and I don't know if you guys want to show the carpet here or the field setup here, which is kind of interesting because depending on how teams are setting up in whether they're in their classrooms or small areas or garages or whatever. What we did is obviously we have the full practice field here, but they've actually marked out on the floor. I don't know if you can see it because he's kind of aiming up. Oh, there's our impromptu. Make everybody dizzy. Okay. So there's the marks on the floor. They just use the blue tape for the autonomous. So there's a couple different ways that teams can approach it. Obviously, you guys are using asphalt, right? So that's fascinating, and people could use anything for this. I think it's a really interesting season for this kind of stuff. You're actually never going to probably be able to do this again. I hope we're never going to have to do this again. But what a cool opportunity to explore things we haven't done before. Do you have anything you wanted to add to that, Teddy?
There's actually, the beauty I think of it is when you're in a normal competition, you have like a set drive team and you have a set everything and you know who's going to be in the pit working on something. But with this challenge, now that we can run our robot through one of the skills challenges 1,000 times and only submit our best one, this really leaves us open that we can let anyone who wants to try driving the robot, that maybe in a normal season that we'd have a set team that would be driving the robot who's the operator. This year, it gives you so much more flexibility, and honestly, I think it's a much better opportunity for teaching and getting more people involved in almost everything because of more time and more flexibility, I think.
Yeah, that's an excellent point. And we're actually doing that with the First Tech Challenge program as well, right? So, different students get to drive, different people get to try different things and have a really kind of safe environment to explore all these different things. And it's not going to critically damage or hurt anything. So that's pretty cool. And hopefully, like you said, if you've got a lot of new students, it's a perfect training opportunity to position yourselves really well for next season. Yeah. What are you looking forward to the most on this particular? And it can be the first at home, whether it's the robot skills or whether it's other parts of it. What is your favorite part of the challenges this year?
Honestly, I really don't know.
Yeah.
I like the freedom that you could also just do a game design thing, which I think is really cool. But I think there's nothing that really is my favorite. I like the fact that there's a lot more flexibility. And I
Yeah.
think the comment that was on Facebook, I think, speaks really well.
That one.
Yeah.
That's a good point. It's an excellent point. It is. It's like one long off season, and that makes it really really interesting. And we're going to be talking about the game design for our next February session. So if you guys have stuff you want to contribute there, that'll be fun to do. Oh, yep. And here's somebody else talking about judging. We actually are trying to get more judges, and we've reached out into the Tampa Bay, business community and manufacturers and companies. This is a great opportunity for folks to be able to get a real taste of what goes on with FIRST programs without ever having to leave your home. So you can do it all virtually this year, and they really need a lot of judges. And you can see just from the students we have here that you get to talk to some pretty cool people about some of the things that they do. And so you guys are going to have to do interviews as well and to present what you're doing, right? So you're gonna have to present on your design and your programming and everything else. Did you guys have something else you wanted to show, or were you? Oh, you were moving around. I thought you had something else going over there. So yeah, I think that's great. And are any students on that? They lowered the age on the judging too. Did you see that? So they lowered the age down to 19. So it's a good time to grab alumni who are might be interested in contributing this season and signing up to be judges for this. Pretty cool.
That's a great point.
Yeah, there you go. Grab them. So the next few weeks. So how often do you guys meet at Royal Robotics?
Monday through Saturday.
That's a lot of meeting. Oh, look at this was good. There we go. Alumni assemble. So you meet like during school or online, you said most of the time, or also in person?
In person for about 2 hours after school on Monday through Friday, and then let's see, 6 hours on Saturday.
Do you have sub teams? Are you broken up in all your different people working on different portions of the challenges?
For the different challenges, not so much. We have like traditional sub teams like a programming and a CAD sub team, but not really for the different challenges, mainly because our team is not very large that it enables that, I think, is a good way to summarize it, and team members' interests.
You don't put the orders on there, Sam, and say you must do.
No, we pretty much let everybody do whatever they want. I try to talk as many people into CAD and programming as possible. Everybody's like, I want to build it. I'm like, no, we got to do.
Everybody wants to build it. Everybody wants to drive it. So that opens up the conversation too to some more opportunities for collaboration. I mean, when we do these events where we can bring some teams together, we've been trying to encourage more teams to participate in these Roboticon chats about the season, because you don't really have the opportunity to see each other like you normally do. Are you all doing anything with other teams where you're getting online with them or speaking or sharing ideas and things? And would you like to if you're not?
I don't know. What do you think, Teddy?
I think it's a great thing, especially when you're in like a normal competition. You can go over to a team next door or down or somewhere in the pits, and you can get an idea, like you saw them do something that you thought was a great idea, which you can't easily do now. And I think working with other teams and communicating like a chat like this is really eye-opening in some ways. I know right now, I don't think we've been talking to very many teams, or if I think just
We're trying to talk to LED Robotics, but
yeah, and that's that I think that adds a lot, because it is fun to hear what you're doing, right? And fun, and I think you can sort of cross pollinate a little bit and get different ideas. You get to share ideas, like I'm putting my parts in refrigerators and hammering at them, and maybe whether or not that's a good idea, but it does work. But I think it's fun, right? Just seeing each other is pretty cool, and I don't think we want to lose that part of it. So I think one of the things we'd like to try to do is get more conversation going, at least in Tampa. We do have the field here we've been trying to encourage students who want to use the field, come out, you do your filming and photography. We've gotten a few inquiries from a few teams that are interested in possibly using the field for running some practice matches and filming their runs and stuff. We're open to that at AMROC. It's amrocktampabay.com, and the teams can go and reserve time on the field for that. Happy to accommodate that, and also happy to collaborate. I mean, they almost have their meetings on Saturdays. We're happy to open those up via Google Meet or some other video sharing platform so that teams can sort of check in with each other. I think that might be fun to do. Maybe we'll just leave that open as here we're available from these times. Come on by and say hi. So I think there's some cool things we can do there. Anything else you wanted to add, Teddy, about the season or what your guys are hoping for or what your next steps are?
Not really. I think we kind of talked about mainly our goals, and unless Mr. McCamus wants to add anything,
No,
I can't think of it.
I think we covered it pretty well.
Very cool. I'm really glad you guys came on. Do you have maybe one of other things that we can add if you guys want to add anything about that? Would you be available if other teams wanted help with anything? And that goes for Royal Robotics as well. If somebody wanted some guidance on some of the things that you're doing or some programming help, you guys open to all that?
Yeah.
Of course. Contact us.
Yep. So we got Edgar Allan Ohms. I know that website. Maybe I can type it. Maybe I can't. Okay. And then we'll throw. I probably spelled it wrong. I think I did. There's like an extra. No, it's correct. And we can throw Royal Robotics in there. Look them up. Go visit. Chat with folks and get some conversation going. And really want to encourage teams to talk to each other. Right. It makes it a whole lot more fun.
Yeah, this has been great.
Well, good. This is fun. And again, if you have any questions about anything, next time we're going to be doing game design. You guys have an idea for game design?
We
you don't have to share it.
Kind
yet.
of
Just wondered
do,
if you had one yet.
but we're still trying to decide if we're going to do the game design or innovation challenge, because we don't think we can get both done in time. So we're still trying to pick which one we think we can get done / which is a better idea, I guess, the other consideration.
Yep. And what about you guys? You were looking. I'm impressed. I think you guys said you want to do all three, right?
Yeah, we're
look
doing
at
all
that.
three. I think we're doing pretty well on doing all three. I mean, obviously skills is kind of it, but the innovation and game design, we have some really good ideas, and we think that's going to go well.
Mm-hmm.
Oh yeah, we definitely want you. I got a question there from Brian. Yes, we definitely want you in for that. We're going to be doing game design next week, and we definitely want Brian. He led our CAD challenge for Roboticon, and everybody had a great time with that. So we're definitely going to have Brian on for that one. It's going to be a lot of fun. I'm really looking forward to seeing what students come up with on that and how they're approaching it. And I'm hoping that first grab some of those cool game designs and we get to see some student-made games for the future seasons. And I know somebody's going to have a water game. I just know it.
Oh, of course.
Maybe a rain game, waterproof robot. I don't know. That's pretty good.
The water game, then we'll do a lava game. Next up.
And if one of you will put the Royal Robotics website in the private chat there, I'll put it into the regular chat so people have that. People can reach out to you. Again, we're happy to keep doing this. We're happy to keep connecting with teams. If you need anything at all, you can find us through Roboticon. You can find us through AMROC. You can find Royal Robotics on their website, and us. And it's a fascinating season. It's a challenging season, but I think we can have a good time getting through it together. If you guys ever want to do workshops or anything like that, we can always run special programs on that. And we continue to look for anybody who wants to help out teams. If you're watching and you want to help in some way, that would be terrific because all the teams can use help. Royal Robotics is in Newport Richey, and the Ohms is here in Tampa. And, this is a great opportunity to help teams and to really, move the future forward for these great students. They're all starting to look at colleges and all that cool stuff. And this is a really great opportunity. So thank you. You guys want to add anything? Did I leave anything out that you guys want to add, Sam and Teddy?
Teddy, you sharing our email address? I don't know if our website is up.
Yeah, our
Is it up?
website is not working well, so I did email
got it in
and
there.
then yeah.
That's great.
Okay.
You guys want to add anything?
Yeah, I mean, I just wanted to say, I mean, especially us on programming, we would really be interested in talking to other teams and connecting. Whenever during meetings, we end up in what we refer to as the programming bubble, where we're programming and we have literally no clue what is happening with the engineering. It's just kind of a black box, and we walk out at the end of the meeting and see what they did or didn't do. But yeah, I mean, I think we really would be interested in connecting with other teams and talking to them. So please, if there's any other teams watching who want to get in touch with us or Royal Robotics or just anyone, please get in touch. We'd be very much interested in that.
Yeah.
That sounds great. I think we may end up setting up just a programming session for folks, because I know there's been some requests about that. So, again, thank you guys for joining in. This is a lot of fun. I like doing these, and I'm really excited to see what our Florida teams come up with at the end of the season. I think it's going to be fun to see what everybody's put together. If anybody has things they want to share for the website, we can put everything up on the Roboticon website. If you've got videos, if you've got resources, anything like that, we have a resource page going on Roboticon, and we can share things up there for other teams as well. So, all right. So, I think I had a good time. I hope you guys had a good time, and I'm gonna wrap it up here. And we had a really good session tonight. I really appreciate the teams coming out on a Friday night to chat. Appreciate Sam being here in Royal Robotics, and we will be back again on the fourth Friday, which I believe is the 24th, to talk about game design. And we'll have Brian Bautista here with us to help share some of his insights, and we'll talk about some of the different things that we can do with that. So thank you guys for watching, and we'll see you again, and good luck with the season.